Hi everyone, this is Oba. I hope everyone has a great week. You had the occasion to look at the material that were shared in Discord. For context, so the last two sessions were about the L2 circuit of the Summa code base. And today we will have Jean that will talk about the smart contract of the Summa code base. And so, Jean, the mic is yours.
Thanks, Oba. First of all, okay. I'll share my screen first. Give me a second. Okay, can you see the screen right now?
Yes,
okay.
Yes, we can.
Okay, thank you. Okay. Yes. Hello, everyone. This is Jean from Summa team, and I have been working on Summa as a developer alongside Enrico and Alex. Actually, this is my first presentation in English. I'm a little bit nervous, but I will do my best. So today we are going to focusing on gaining a deeper understanding of and how to interact with Summa smart contract. And also I want to mention in the middle of a session, I will check the question in chat and I will answer that if it exists. Okay, next. So you guys are familiar this slide picture. And actually, in the previous two session, as Oba already told me about, we had the Halo 2 and our Summa Halo 2 circuit code review we had. Enrico effectively deliver insight from our repository structure to circuit design and many other things. In today's session, I will focus on the Solidity contract in Summa. And before we going too deeper, I would like to quickly recap the proofs and a commitment introduced in the first Summa session. The Summa flow, there's a three element, briefly two proofs and one commitment. The first one is the proof of ownership. It's not a zero knowledge stock proof, but it is used for verifying the ownership of address by signature verification. We will look at this in more detail later. The second one is the commitment associated with the custodian's liability. It's basically it's a data records that includes the root of Markov tree and total balance of currency and other relevant information at the specific round. Unlike the proof of ownership, the custodian must submit this commitment in every round. Lastly, we have the proof of inclusion. This is a snap proof that generated from Markov tree circuit. So the custodian sends this inclusion proof to users individually. Of course, the proof is not publicly published. And some more. So, yes, I would like to add a little bit more about these three components. It's important to understand that the ownership proof operate independently from both the commitments and the inclusion proof. So in every round, the user needed the commitment for the specific round to verify their inclusion proof within contract. So, however, the ownership proof is not required for verifying the inclusion proof. Okay, now let's proceed to examine these three, focusing on their implementation in Summa contract. Oh, okay. Oh, yes. Okay, people are going show to proof of ownership code, or mentioning about our optimistic approach. We have adopted an optimistic approach or to proof of address ownership. This decision is primarily based on the assumption that the custodians will maintain their reputation and refrain from engaging in malicious activities. For example, if a malicious custodian, they can submit proof of address ownership that has already been submitted in another custodian's contract. The user may consider this act as one they undermine their trust. So, and another reason for the optimistic approach is the design of Summa to encompass all type of cryptocurrency. So the requirement for on-chain asset verification should be minimized. So as a result, the Summa contract assumes ownership of a given address without any signature verification step. Mm, uh, by the way, the verification of proof of ownership is expected to occur off-chain by verifiers, some verifier who incentivized to do so. I believe that on-chain analytics organization or something similar business firm have a significant interest in these account address for their businesses. And also they have has a sufficient motivate to verify and track the balance of these the custodian addresses which are published on the Summa contract. Okay. Now back to one more thing I missed in here. So as I guess some previous session, there's some mentioning about the signature generation is not within the scope of the Summa project. You may already in later, each custodian generate the signatures for the proof of ownership according to their operational method or something and submit them directly to the Summa contract. Okay, let's see. So as I mentioned a little bit earlier, our aim is to support a wide range of cryptocurrency, including those non-EVM compatible one. So the address ownership proof consists of 4 fields, as you can see on the slide, the right side. The address, chain, signature, and message. I would not go into every detail as the concept is very straightforward, but it's crucial to understand that the signature in here is generated from the given message under that. I want to note that the custodian can set this message each time when submitting proof of ownership to smart contract. Moreover, the Summa contract does not verify the signature validity at all. And yes, there are 2 reasons I want to mention. I want to add these choices. First one, checking signature from the non-EVM chain on Ethereum is not only hustle, but in some cases, it's technically unfeasible. And second one, the process of validating these details on the contract can use a lot of gas. To keep our contract cost efficient way, we have designed it so the user can verify signature on their own way in off-chain. This approach allows us to work with many different signature schemes, not limited to ECDSA. Okay, just okay. I think it's maybe quickly time to visit our code in here. So yes, can you see this one? Okay, this is I haven't talked about all these things in the only summa.sol file inside the contract folder. So you can see that this commitment structure. You may quickly notice that this commitment is only storing the record by, and also I didn't add the slide, the how to add this commitment through this. The method is here, line number 112, is a submit proof of address ownership. There's some checking requirement statement, but there's only checking the length of the array or duplicate or something basic one. There's no checking signature validation or a similar thing. Okay. Now back to the liability. So yeah, no. The one, yes. That's I want to saying about all the proof of ownership right now. Next one is liability commitment. The commitment struct has also 4 fields: the Murchison tree root, the array of balances, array of a name of a cryptocurrency, and the array of a name of a chain. Each cryptocurrency is mapped to chain one-on-one. For example, the burst balance on the array of root balances is mapped to the burst array of the cryptocurrency name and also the blockchain names too. So the length of these arrays should be always the same when submitting the commitment. Like in the ownership proof, there is no verification for these four fields. The contract checks only the length of array2 in here, but the root and balances are used in verification of inclusion proof. You can check in later. Right now, the other two fields, the currencies and blockchain names, are not used in the contract. These fields are only for recording as the ownership proof. I mean, the ownership proof. Okay. Okay, I think I also have oh, okay, that one, maybe later. Yes, and the commitment is eventually stored in the commitments mapping with the specific timestamp, which is given by custodian. As you know, the commitment should be unique at the specific time. This one is not duplicate. So in every round, custodians submit the commitment that includes Microsoft tree root, which is generated from this a snapshot at the specific moment, and name of currencies and name of chain and also when the custodian submitting the commitment, it is like an announcement that they are solvent to their users' balances, and also mean it start new round at the given timestamp, which is specified on submit commitment transaction. Okay, let's take a look in the code level in here. Or see, it's only difference from the proof of ownership. The Microsoft tree root and balances is used in verification of inclusion proof. And yes, the other code, event emit is a default one. I do not want to explain those the tiny thing. It's okay. The last part is proof of inclusion. Yes. This proof of inclusion is a key point of interaction for users with the Summa contract. This is the proof in the mentioning on the slide is proof is a snark proof, not just a different in ownership proof mean. So user can obtain the proof alongside with the public input and timestamp for a round, for specific round, different directly from the custodian. As shown on slide, the public inputs are present as a byte, serialized bytes, because there is no defined structure for public input in Summa contract. And also, it's the public input is generated from the backend method name of gen proof solidity call data. You can check the detailed logic in the link. You can find that one. here. And so under that, there's you may already aware that the public input is the instance values in the circuit. Okay, so the public input, the bytes is sequences start with the leap hash in here. Oh no, sorry. Leap hash and right hash, and followed by the root hash, and then series of root hash coming. It's defined by n n currencies in the circuit configuration. For additional information on how the public inputs are generated and their appearances in test code, you can check this link on the slide too. You can check that out. Okay, no one. So okay, user who want to verify their proof inclusion can do simply executing verify inclusion proof method with their proofs and public input and timestamp all data. Of course, they retrieved from the custodian, and the user can verify their proof on the web interface like Etherscan. As far as I remember, in the first session, and it already showing about the Etherscan interface. The user just push input those three argument, and they can just check the validation on that. Okay, there's some question. We'll quickly answer that one. With leap hash as one component of public inputs, does it mean it's different for all user? If yes, why not have the same for all user? I think it's leap hash is each user has a different leap hash. For example, leap hash is user ID and balances, a hash of balances. So if yes, is the number of currency does it circuit and the different sorry, too confusing. So the answer for the yes and the why not have the same for all user? Because if we have it's no, it cannot be the same leap hash for all user, because we generated the leap hash from the user's entry. The user's entry has a name and unique name and balances, so they cannot have the same leaf hash from the Markov tree. And the second is question.
Just to rephrase maybe the answer for
Mhm.
the first question. So
Mhm.
each user is corresponding for one leaf hash, and in it there is the balance of this specific user. So, yeah, so each user will have a different leaf hash.
Thank you.
Yeah. Sorry, you can continue, Jen.
Okay, thank you. Okay, so which one is question? N is sorry, my chatting has quickly disappeared, I guess. N is the number of currency. Yes, N is the number of currency. Is the circuit allowed to n to be different from one instance to another? No, I really, I'm not fully understand the question. Does the circuit allow for n to be different from one instance to another? But I can answer
Clarify,
like,
Jim. I can
I'm
clarify
sorry.
that, but I can clarify that. What I mean is that
Mm-hmm.
if the number of supported currencies, let's say an exchange started supporting another currency. So now instead of n being 10, we have n is now 11. There are 11 currencies in total. Does the circuit need to be changed because the number of supported currencies changed?
Yes. Actually, I will explain the next slide about that. Maybe check the answer. If not, maybe can ask again at that. Okay. The answer is yes. We have to change the this Summa contract and other things.
Okay, I think that we can continue, Jim. There is no more
Okay.
question. If you are clarifying this one after, I think we can go.
Oh, okay. Okay. See. Okay. Although the not shown on this slide, the function verify inclusion proof function. Also, I didn't mentioning about the from the start. Okay. Let's describe how the verify inclusion proof method briefly. When the verify inclusion proof function is called, it represents the commitments mapping, as you can see in the underline, using the provided timestamp and then checks the root hash from the public input with the commitments, which is the already submitted by custodian. Also not shown this slide. Yes, this function is also verified that the root balance within the public input matches the corresponding root balance recorded in the commitments. Let's check the method just quickly. Yes. As you can see, first time there's a two requirement statement. The first is matching the marker root, and second one is root balance, which means the total balances in the commitment, and also the public input should be matched in that, except the leaf hash in that case. Okay, actually, this is the last slide, and I think I can answer the few mystery thing in the chat question. So in here, and so I have not detailed discussed in how the proof in the field and the inclusion proof. The proof input is verified within the Summa contract. The truth is we use proof kind of snark proof verifier named inclusion verifier. That's all. You can check the file. It is located in the contract folder. The inclusion verifier actually is generated with the Merkle-centric circuit configuration, namely levels, n currencies, and n bytes. This implies that if a custodian needs to change their proof configuration, they would need to generate and redeploy the inclusion modifier. For example, I'll give you an example. If a custodian wants to include a larger number of currencies in a inclusion proof for their users, say expanding one currency from one currency to 3 within the single proof. The custodian, they must regenerate the inclusion verifier with updated configuration. In example case, it's end currency equals 3, not 1, and then they have to redeploy it. Yes, that one. Yes, there's can see some question. Maybe I can check that for now. Second question is
they are answered, I think, from Alex, those questions.
Thank you. Yes, Alex already answered that question. Thank you. And that's it. I think it's the Summa contract itself is not too difficult logic in here. And also, I believe the Halo 2 verifier, proof verifier is not in the, I mean the generating, I mean the inclusion verifier generator of inclusion verifier is not in the scope. You guys have to check the inclusion verifiers too, but I believe is the U code is a little bit messy about that. Oops. Okay, this link is it's broken, I guess. Maybe check I will show the inclusion verifier a little bit. Okay. Contract and service. Yes, there's a 2 solidity contract in the contract border, and the inclusion verifier is here. There's an assembly code there. The main thing is there's a much better for now. Yes. It's all method is related about the EC curve operation. At the end, you can find one in the pairing check or the verifying the AGG increment thing. Yes, you can check that one too. Okay, I think I'm done in today. What I prepared. If you have any question, things I can wait.
Thank you very much, Jin. If any of you have question, please write it in the chat, or you can raise your hand.
Oh, please.
Yeah, thank you, Jen. This was excellent. So I just wondering if you can clarify. So we have the optimistic proof of ownership on the one hand, and we have proof of inclusion on the other hand. I'm wondering what is the meeting point? What is in what way does the proof of ownership implicitly factor in the proof of inclusion? Because the custodian is not just proving that they have a correct sum in a tree. somehow the proof of ownership has to factor in the proof in all of the proofs of inclusion, right? So in what way, if you can clarify, in what way in the circuits do the proof of ownership of addresses factor in creating all the proof of inclusions?
First of all, I think you got point out good point. And also I rephrase your question in what I understanding is that the proof of ownership, what's in the easy way, what point of proof of inclusion is related in the inclusion, I mean the proof of ownership related in the proof of inclusion of the, which is for user, right? So
Yeah,
I
exactly. That's a
can,
good way of rephrasing it.
yes, the there's a good point because we did not implementation or searching and other things did not to provable ownership. But as far as I research it and we discussed it, I can summarize that too. Mm, uh, let's focusing on the when the user verifying their inclusion proof on the contract. See, the user only know about their own the leaf hash and the root hash which is already published on the contract and the other total balance of root balances. The user only know that and they just want to this number and is correctly computed in Microsoft in the stock circuit. That's it. But the user really want to check these root balances correctly uh, uh, custodian posted or custodian uh, correctly committed. There's a no constraint in the Summa protocol at all. But we give uh, the data storage in the smart contract who want to these root balances are correct or not at this given specific time. If the time, let's say this round is started at T1, there's a 10 proof of ownership already submitted before T1 timestamp. The user who want to check these root balances correctly posted or not, they have to reversely track these balances of the proof addresses in proof of ownership. But I know it's not that easy one, but it's possible.
So right now,
Is the,
root balances is not in any way linked or validated against the total amount of a currency under an address that has been proven ownership for. The two are not linked in circuit in any way. This is something that the users have to observe or check.
yes, yes,
Okay.
that's correct. Yes, and I already mentioning about these addresses are quite interested from the many on-chain analytic firm or any others. So they always track their the custodian or exchanges total balances. So user rely on their services or similar stuff. Yeah.
I'm wondering why though. Why not check in circuit that the root balance
Mm,
of a certain currency is equal to or greater than the amount of currency that has been proven ownership of in a specific address? I guess that means
mm,
you would have in circuit to implement a proof for certain signature schemes like the Bitcoin,
mm,
like signatures, Ethereum, Solana, whatever.
mm,
Um, but it's I guess this is the difficulty in doing that, is that you would need to
right, right.
verify in circuit these all
Uh,
these various signature schemes, right?
yes, true.
Maybe I can add a couple of words here.
Alex.
Can you hear me, guys?
Yes, I
Yes.
can hear you, Alex.
Oh yeah, great. So first of all, let's think about what should be the input of a circuit and what shouldn't. And here, the input for the circuit is something that is specific, that is very specific for the data structure that is used to prove the inclusion. And the data structure is the Merkle tree, and it operates on user balances. So if we have an opportunity to verify the address ownership on chain in some way, we would rather do that on chain because it shouldn't necessarily be a part of the circuit at all. But then we come to a couple of problems if we really wanted to verify, not just verify the address ownership on chain, but also perform the aforementioned check that the balances of these addresses are actually sufficient to cover the liabilities. And the first part of it is that, yes, verifying signatures from foreign chains in EVM is very costly, of course, in many cases, because it's not a native EVM operation. But then there comes another problem, is that we actually need to only verify that the custodian owns enough assets at a certain moment of time in the past when the proof was generated. And this brings us to the second part of the problem, that there are currently no, I would say almost no oracles on chain that can provide historical data, especially about other chains. If, for example, if for EVM or more specifically for Ethereum, there exists Axiom, that is a pretty sophisticated project already because it generates zero knowledge proofs about the past on-chain data. So you could imagine that integrating that would already be like an ordeal. But such an oracle of past account balances for other chains, to my best knowledge, it just doesn't exist at all. Most of the oracles, they only provide you the the current price data, not even account balances. So there are like two major technical challenges about verifying the address ownership and also verifying the actual balances of these addresses. That's why we decided to carry it out off-chain, because since the data is forever recorded in the smart contract, it is always possible to actually go to any chain's block explorer and just take a look whether that address really had that balance at that moment of time.
But Alex, just to follow up, in principle, wouldn't it be, it would be possible for the EVM to check a proof about a proof of a signature scheme? So you could prove ECDSA in circuit and then verify a proof about it on chain. You can prove a Solana
Yeah,
signature
absolutely.
scheme.
And even more, as I said before, it's just enough to check to verify the signature on chain, not even inside the circuit, because there is no need to prove anything about the signature in a zero knowledge way. It is simply because the exchange is not hiding its address, right? The exchange openly says, hey, take a look, this is my address and this is my signature. And all of that is public, and you can simply run the signature check in a smart contract, not inside the zero knowledge proof.
Hmm.
Thank you very much, Alex, for those information and explanation. I think there is more question in the chat. Maybe we can go over them.
Okay. It's a question from the Aish. How is the CSV of ownership published? Yes, you can publish it ownership proof of ownership from the CSV file. We name on as the signature.csv file. The custodian generate by themselves this message and signature and other exchanges chain and other things, and using the signature.csv file and send it to by the using backend. It eventually it triggered submit proof of ownership method in Summa contract. Oh, there's some more question, but it's deleted, I guess. Oh, yes, Igor, yes. It's still might not be possible to see address balances specific timestamp through zBlock explorer. Yes, it's true. But these information, the specific time, the balance of these addresses is I already mentioned the on-chain validate on-chain analytics or organization. They always track that, so it's not it's easy to access to publish it to any other services right now.
If we go even deeper and we take a look from the technical perspective, is that really is that possible? Then it all comes down to the fact that blockchain is stored in its entirety. I mean, to my best knowledge, like most of the chains, if you run a node, then you have to sync the entire blockchain history from the Genesis block up to now, which means that even if there is no block explorer with a page available online, there will always be a node that is accessible, and you can just query a balance of an address at a certain point in time from a blockchain node. Otherwise, if there was no such information, the blockchain just wouldn't work, because you wouldn't know the history, and you wouldn't be able to validate the subsequent blocks.
Thank you, Alex. Add more.
I think that the Igor had a remark is that you need an archival node to check all the chain. But yeah, and there is another question, I think.
Oh, yes, about Aish. If every user is served CSV differently, can a custodian owning A and B key send B signature to A and vice versa? Yes, they can. Yes, they can. And
I think
if
I
they,
don't really understand this question.
well,
There
I
is
think,
maybe a mix of proof of ownership and proof of user inclusion in this question.
oh, yeah, I thought that the question about the proof of ownership, yes, is that asking about the proof of ownership?
Because we're not serving CSVs to anyone. CSV is used internally in the backend of the custodian. It's just like the custodian's database, basically. In our project, it's represented with just a CSV file. So it's basically the list of user balances that the custodian is using internally to generate the Merkle tree. And then every user is served the proof of inclusion, not the CSV.
Yeah, so this question is just about ownership. So my question is like if let's say the custodian owns everyone's keys. So let's say my account is also owned by the custodian, and I have some let's say some Ethereum in my wallet. So to someone else, can they serve uh, my signatures because they own the key, and I wouldn't ever know about it because I don't see that.
Well, first of all, there are no signatures because we're not talking about the real on-chain wallets. This is like a centralized custodian. Like you can think about a centralized exchange, right? On the centralized exchange, you're just basically trusting the web page that you're looking at. And if that web page is saying that you have 1 ETH, and you still remember that actually, yeah, you had 1 ETH yesterday, then basically that is the way how you trust them, right? So, and for this reason, like this is the first part of your question, and the second part of your question is how, like, why can't an exchange send the same proof to all the users who have 1 ETH balance? And also, not just that, why can't an exchange include such a user only once and send that proof to, let's say, 100 of users who have 1 ETH balance, and by that understating the liabilities by 99 ETH? Well, the answer is simple. It is because in the leaf hash, we also have an user ID as an input to that hash, besides the balances, which is probably something like your email, which means that when you receive the proof, you can actually check that the leaf hash checks out with your email and your balances hashed together. And this way you will be sure that if the custodian tries to share the proof to with any other users, then of course they will notice that this is just incorrect.
Thank you, Alex, for this explanation.
If I may clarify to Yash, when you deposit to a centralized exchange, you are not giving the exchange your key. You're actually transferring ownership to an address that they own. So they don't have access to your key. It's just you transferred the money to a key that they own. And the second, maybe slight clarification, it's basically a different way of what Alex was saying. It's like the proof of inclusions, the balance in the root is a statement about a sum that we have added up some numbers and they added up to this sum. And there is nothing in it, as we said earlier, about cryptographic proof of ownership over an address. That is something that the users independently verify in the other optimistic proof that has been committed to about a big cold wallet that the exchange has. I have ownership of this massive amount of ETH. So the two are not, they are different type, the statement being proved is different in both cases. In nature, I mean.
But in reality, even the custodian doesn't own the private keys, correct? The actual exchange, centralized exchange implementation, they outsource it to somebody else. So even the custodian cannot actually verify an individual user's account, correct?
Typically, these big exchanges, they have big cold wallets that hold the vast majority of what they own, and you are right now a lot of them outsource ownership of the private keys and the control and maintenance of the private keys to other custodians as well. That's true. But as far as security assumptions are concerned, it's basically not that different if you are trusting the exchange itself or someone else behind, someone else on behalf of that exchange. It's the same trust model, kind of.
Thank you for those clarification. I think that we have one last question and from Flying Nobita, but Alex is already answering this. So I think that's
Yeah, maybe it's worth saying it out loud because we had like a small discussion with Flying Nobita about what does it mean to own the contract, and as I replied in text, it's a common pattern in smart contracts. There is no really such a thing as a contract ownership, so it's like an algorithmic pattern where you assign a certain address as an admin or an owner or any name that you like for that role, and then you can designate specific functions of the contract as only callable by that address. So like ultimately you can have as many roles as you want in the contract. Right now we have like a pretty simple contract that only has one owner, one role. And then we had a small discussion about why can't we just deploy a single Summa contract for all the exchanges that are potentially willing to use it. Well, first of all, just for simplicity, right now we're not doing that because we haven't yet implemented it in production. So we haven't heard back from real exchanges who say, like, yeah, we would like to all cooperate together and we would like to have a single contract and we all will be committing our liabilities to a single contract. If that happens, then of course it will be very easy to refactor the contract to just maintain the separate Merkle roots and address ownership proofs, or even cross-check the address ownership proofs so that two exchanges are not using the same address, for example. But right now, since we don't have like a real deployment for real CEX, we just don't bother that much about this aspect. But it's easily it can be easily refactored, yeah, if necessary.
Thanks. Just want to clarify on that. Like as far the way I'm seeing this right, understanding is right now is that the signature and the proof of address actually it comes down to the CSV, right? That's uploaded, where it's got the chain address signature and the message. So who owns the contract? Like it actually doesn't really matter, right? And then I guess my second question is like yeah, I guess maybe it just goes down to what I was saying before, like in the chat, which is like if that was in production, like if every exchange, or maybe a better way to ask it is like, if the exchange were to deploy their own contract, in what ways do you see them change the contract to how would they change the contract such that it would fit themselves better? And if this would introduce new security attack because of this. Yeah, hopefully that was clear. Thank you.
Yeah, regarding the former, I would only add that you can view ownership of a contract as just write permissions, like as we have in like operating systems, like in Linux or Mac, where if you're not allowed to write to this directory, you will not be able to. So the same with this contract. Right now, only one address can actually write something, so that, for example, you as a user, you can only call that view function to verify your inclusion proof. But as a user, you would not be able to write something into the contract, like write some kind of root or an address ownership proof. So it's just barely to prevent unauthorized write access. And the second part of the question, what would an exchange deploy in a different way? I would say, like, what comes to my mind right away. The first thing is, of course, the particular configuration of the circuit. For example, exchange A can maybe can allow trading maybe like 50 cryptocurrencies, and then an exchange B maybe allows trading 100 cryptocurrencies. So of course this parameter will already be different, and the number of user balances in the Merkle tree will be different. So the verifier for the user inclusion will be different in this case.
Sorry, okay, thanks. So just so you clarify, when you say the contract, so the exchange will upload their own inclusion verifier as well as Summa dot. So both contracts, they have their own versions, right?
I'm not sure about that, because if you take a look at the Summa.sol, there is not much to tweak, to customize. It's pretty simple and pretty general purpose. But of course, it all comes down to the interaction between the exchange and the community in this case, I would say. Because, for example, if there is a general purpose version of the system that is good enough for everyone, let's say it's a verifier that verifies like 300 balances for a user base of like up to 2 to the 20th or something like that, that is good enough for everyone, then everyone knows what the code looks like, because the code is open source. And if the code is audited and the contract is uploaded to Etherscan, let's say, then everyone can just check that if the next exchange deploys something, it will be obvious if it deploys the same code or if it deploys something else.
Got it. Thank you very much.
Okay, perfect. I think we do not have any more questions. So thank you, everyone. It was really interesting, great presentation, and Q&A session. Have a good day and see you on Discord. Bye bye.